All right, then let's talk about May. Okay, monthly review for May 2025. I'm going to start with the shout outs to the community again. A couple of little shout outs to people who were sharing ideas and papers. So Rick was sharing a paper about zero-shot learning with reinforcement learning type approach. Blimpy Way shared a paper about thoughts and causal effectiveness of thinking. And then Jeremy LL asked some interesting questions about a project he's thinking about for using Monty on a phone. We also had Ski 9865 sharing his progress on using Monty for digit recognition on the MNIST dataset, and a lot of interaction there. Several of us have replied here and given tips, Scott, Jose, and me. And then this is a really great contribution I really want to highlight. So Colin, who introduced himself, I think, last month, actually came back with some really interesting results. He looked at, so one of the slowest operations in our code currently is the k-nearest neighbor tree search that we're doing. And so Colin looked at a couple of alternatives to the KD tree search, both on CPU and GPU, and basically evaluated them against each other for both query time and build time, and then different batch sizes as well, and shared those results on the discourse forum afterwards with some like general takeaways, which is for evaluation heavy workflows, we might consider using a GPU implementation, but since Monty is kind of made for continual learning where we keep having to update our models, KD tree search is actually already quite optimal for what we're doing in that case if we have to build trees frequently, which yeah, is a good insight to get. And then also had a first community organized meetup. I'm not sure how it went, but apparently there was a meetup happening in San Francisco a couple of weeks ago, which is pretty exciting. And then, yeah, people are sharing Thousand Brains project, which is also great. So there's a podcast I was on, and then a couple of people just kind of commenting on other people's posts. I think on Jan LeCun's posts and some other posts where it's like, check out the work of Thousand Brains project. And yeah, reading Thousand Brains Theory by Jeff Hawkins and Shockwaves Through My Mind, such amazing ambition. And yeah, here, Drew Ryan, Inner Tone. Thousand Brains project is doing exactly what you said, taking human brain architecture as the reference point for general intelligence. What surprises me is that Jeff Hawkins at Numenta and Thousand Brains project have been doing exactly this kind of research. They have a very convincing and neuroscientifically accurate theory, quote tons of literature, and even publish all of their research meetings on YouTube. So yeah, that's exciting to see, and thanks to everyone who is sharing this project. It's definitely very much appreciated.
Okay. For the recording, we wrote down all our feedback in the hackathon code feedback document that's linked, and we all voted on what we're going to discuss. Looking 2 votes, 2 votes, 2 votes, 2 votes, 1, 3 votes. Okay, so first item, so we talk about is I can't use my own sensor ID convention, and I have to split one sensor into 2 that use depth and RGBA suffixes. So like this was an example that I had to do here. Initially, I was just returning from the environment state, I was returning a sensor and it only had a patch, but I couldn't do it because patch.depth and patch.RGBA were hard-coded expectations for the sensor state, even though, as you can see, it's just they're fully coupled to each other. So there's some assumption that's built in here. So that's the problem that I encountered. Vivian, you have two other items above that seem to refer to the same issue. Which
Well,
ones are you?
I guess it's not the same issue, but there were two other that we're kind of referring to that they're confusing naming conventions of calling things patch or sensor module 0 and like implicit assumptions in other places of the code that you're using those names, which seems maybe related. I guess one comment now that you showed this code snippet is that I totally agree that it's a problem, but it's only a problem, I think, if you're just customizing a certain part of the code. So for example, when we wrote our hackathon project, uh, we're able to return state with like no RGBA or depth because we have ultrasound. So we just called it ultrasound, but that was possible because we also wrote custom sensor module class that then expected those, that then didn't expect those. I think the main place where it is where you probably encountered the issue is in the depth to 3D locations transform, I assume. And in our project, we didn't use that transform. So maybe that's why it wasn't as big of an issue, but yeah. I'm not sure. Do you remember where that expectation was set that it has those two fields?
Yeah, I think it was in the depth, yes. Depth to 3D. If I'm, yeah.
Yeah, that sounds right. I can't remember where the.
Okay, yeah. I guess then the question is like, how general do we want that transform to be? Generally, that transform requires a depth channel to be able to do anything, and then its purpose is to transform the RGBA channel into like to return that in a different format. So it kind of requires those two fields. But then yeah, it wouldn't necessarily need them to be called exactly that. So we could, like in some other places, we have variables that you pass to the function that tell where you pass like what's the name of the field that I want to use for the depth channel.
Yeah, and the other thing here, I mean structurally, right? Like because you're given a dictionary and you're hard coding a key, like that's the coupling, right? Like what you just
Yeah.
said. And this pattern happens a lot in the code. So just feedback would be avoid this pattern of like of magically knowing what property to access on an object that was passed to you. Just like have whoever's calling you make it their responsibility to give you the right thing. Don't be and like especially like in a generic dictionary. So that's sort of the pattern to avoid there. As to the yeah, I had some questions about how generic these transforms were supposed to be because they get my experiments. So they get specified here. So it's like this thing, right? So by the way, this is what I know you've probably never seen this. This is what a flat configuration looks like. Never seen in the wild before. But so in
I
the
tried to do
transform,
the same for our ultrasound project this time too.
I think that says a lot about usability of configurations. If we both the teams went with the flat config. Um, the so the data set. So this is what the other aspect was confusing to me. This is a data set configuration. So so there's a transform that's happening on the data set, and this happens inside under get item implementation. So when when we tell the data set to give me a thing, it gets an observation and state, and then it transforms the observations themselves. Shouldn't this be happening in like sensor module or something like
Yeah.
that?
So for a bit of context or history, I guess. First, I'm not happy with this, and I agree with you that kind of by how we think about the sensor module, this should be happening in the sensor module to kind of to transform incoming data into the CMP and get the world coordinates. The reason why we have this kind of data set up that then applies transforms is because when we first started out writing this code base, we wrote it using kind of 10 Torch conventions. And in Torch, they have like data set and data loader and transforms. And it's exactly that kind of setup. And the original idea was that this will make it really easy to then just plug in a deep learning system and compare to that. But we never really did that. We did it with, I think, vector neurons once. Because like deep learning systems aren't really made for interacting with environments and learning continually, and we are not learning from static data sets. So we kind of set up the repository to be made for static data sets, even though we're not working with that. So yeah, long story short, I'm not a fan of it.
Okay, so to me, what I'm hearing is, this sounds like, okay, so the transforms themselves will become part of the sensor modules. That's part of the refactor of going away from dataset data loader and just finding a different place for them. But yeah, that makes sense. I'm tracking that then.
Yeah. Okay. I was going to say, yeah, we already have that noted somewhere. Otherwise,
Yep.
want to make sure we cool. Put it in the notes.
Does anybody else want to discuss any of this further? Okay, let's go to the first one with 2 votes. Hodge and Jeremy voted for embodied environment has abstract classes that seem too specific to simulators. Add object, remove object, close. If you wanna share maybe a screen too. I just happen to be familiar with the previous one. If you need a screen, let me know to better discuss this or whatnot.
Yeah, I think I added this item because when I was customizing the embodied environment, I had to write these like boilerplate classes because they're in the abstract class, even though they're kind of just for habitat, made for habitat. And I might have been the one who actually added it, but I don't remember why it should be part of the abstract class, and I think it should not be. But
I ran into a very similar thing. Again, please, if you want to show your code or something, go ahead. I just remember working on this as well. Environments. So I think so I just skipped that environment, I think, right? Because the problem here was embodied environment has abstract classes that seem too specific to simulators. Like, yeah, so I just inherited directly from embodied environment because I didn't want that add object stuff. So when we implemented everything as awesome environment, we just went directly from embodied environment.
hang on, but maybe I'll share so what we
please.
did was also inherit from embodied environment, which I think is the abstract class, but then it requires you to implement.
Oh, yeah, I see it.
Raise not implemented error. Ultrasound environment does not support adding objects. And I saw this pattern in a couple of other custom environments too that are not habitat.
Oh yeah, I just scroll down and I say I put raise not implemented error. A bunch of stuff myself here. Like okay, I don't think you shared, so I'll reshare again. Yeah, this is what you're talking about.
Yeah, exactly.
We just needed to raise implemented error. Okay, yeah, so that's just it's too coupled to yeah, this fun it feels like this is definitely a Sims simulator. So maybe it's just coupled to a simulator too soon. Maybe there's a more generic environment.
Yeah, because I think we have a habitat environment class that inherits from embodied environment. And I feel like that would be the place to have those. Or have like a simulated environment class.
Okay.
Yeah,
Yeah.
I think
That's
too strong of a requirement.
what immediately goes in my head is we probably just should have environment, and then there's a simulated environment, and then maybe embodied environment, and those are like the simulator one has, you can add objects to it, versus the embodied environment maybe has something to do with other things, like positioning you in a place or something like that. Okay. I mean, this makes sense to me. Um, let's see. Think.
Yeah, I
I'm
don't
just gonna
know,
write my
OJ,
note.
Jeremy, if you had some comments on that since you put your name there.
I think mine was more around just the general, that's something I've seen in a lot of places of stuff being too tied to simulation environments, and kind of want to discuss that more. But this is, good. Although looking at that pattern that y'all did in both of those reminded me of, like, I've never actually used abstract base classes. Like, we never used that in Bitbucket. What we would do is we'd have a base class and then kind of manually implement the methods and have them throw not implemented, and usually have it pull the name of the class off. So if you subclassed it, it would still give you the message saying this is the class that doesn't implement this. And that might be something you could do here, is like make those methods optional, really. But I think I like the idea of like embodied versus simulated a little bit better than that.
Yeah, so in my mind, the reason we have these abstract classes is because we want Monty to be this very modular and customizable system where you can just write your own learning module and plug it in with all the other existing components without changing other stuff. And so having the abstract class gives you kind of the boilerplate of, like, these are the functions that the other components expect this class to have. And makes it kind of a bit clearer to, like, all right, I want to write my custom learning module, so I need to implement those 5 functions. But yeah, I'm
I
not
think what you
a
described is exactly like a protocol, actually. Like protocol is,
yeah. So
I mean, yeah,
yeah, basically
yeah,
defining the kind of
like
interface of
a
that.
like a template, yeah,
The
yeah.
difference between abstract class and a protocol will be abstract class will fail upon initialization, versus protocol will fail at runtime.
Yes, I
So
understand.
that's the trade-off. It's sort of arbitrary where we do it. Depending on our
Oh,
tooling, right? For protocols to be useful, we need the developers need to have type checking, say, sort of tooling implemented as part of code development.
yes. Which I don't think we should do right now with lower versions of Python, and even the latest version, typing is still kind of changing a lot. So, anyways, yeah, I think I put it for the same reason as Jeremy. But I had one more thing to say, but I now forget what it is. Oh, I thought the abstract base class, like, just correct me if I'm wrong. Is it also partially used for testing? Like, so I don't know testing very well, but I know something about like mocking objects or something like that. Like, I know there's like some fake buffer, fake agent thing. Does that do those require abstract classes or no?
No,
Okay,
you can mock any class.
okay,
And generally in Python, it's all duck typed, right? Like, you just call it, and if the method's not there, you get a attribute error or whatever, right? This
yeah,
sort of like abstract class is more of a more strongly typed language type of thing.
okay,
The fakes aren't there to wrap abstractions. It's just to provide fake implementations for the purpose of testing. But fakes would be there without the abstract classes as well, just so they could be help the tests.
all right, thank you.
All right.
So yeah, and in my mind, I guess I still see a lot of value in having the abstract classes for now, because it's like all in one place. It tells you, all right, this is what is expected of this class. An environment should implement a step function, a reset function, and I don't know, a pre and post episode function, and then you just see it all in one place. We could add a little bit more documentation to what these functions should do or something like that. But yeah.
Yeah,
Um,
no, I agree. I think it definitely has value, and I think, just as you guys have kind of identified, it maybe just needed to be made more abstract, and then kind of, yeah, simulated environment or whatever has these kind of more specific things.
Okay. Let's move on to the next thing with the 2 votes, which would be this one. There are multiple libraries used for defining orientation. SciPy rotation, quaternions, they use different quaternion conventions. It's like I'm laughing because we have our Slack threads on this just now too. They use ordering of quaternion. This is scalar last or scalar first. W being the scalar, XYZ being the imaginary. Can be confusing, may lead to errors. Rami Hoje, whoever wrote this, discuss.
Oh, I just think that the order is slightly different from also the problem of having multiple libraries that are doing the same thing. I don't know why we have SciPy rotations and also we have just quaternions that are like quaternions seem to be defined in earlier parts of the code where we had like the habitat simulation stuff. Maybe it requires it, I'm not sure, but
Yes.
if you
So the quaternion package is like an extension of NumPy so that it would allow for, I think, it's like a very janky one. Like I actually looked into this and I wanted to get rid of it because I think we only use it in like a few places, I think.
Okay.
Yeah, I think we use it
Yeah.
in the interface with Habitat.
Yeah.
does it require it? Like
I'm not sure. I think Lewis wrote that part of the code. I think it does, but we could probably put it even further towards just the interface with Habitat.
Yeah, I'm not sure actually, because I know Habitat has, I feel like they have their own quaternion thing, which they've like is in their kind of C++ or whatever implementation. So I don't actually know if it is essential.
I don't think
Um,
Habitat requires it, but I think we have it so that it will. I think it's just a matter of us using that or kind of us just transposing things to put it in the right order. So like we may be able to get rid of the dependency at the cost of clarity, I guess. Clarity as in like, okay, quaternion, I mean, that package will say like it's in this format, but we just manually kind of implement it in some sense. I don't exactly know, but my I guess reason for putting it on was just like let's decide on like ordering at least as a group, and so that we can at least like stick with it. So like everything will be converted to that, so that everybody knows that anything that comes out of Monty will also be in that ordering. And if they have to visualize using OpenGL, they will know, okay, which ordering I'm getting and which, if I need to transpose or not. And like I
yeah, I
know,
think
so
that's a good
OpenGL,
suggestion. Yeah.
yeah. So from so I know OpenGL and Blender. So I think it's like visualization tools and game like Unity use XYZW. While like science libraries like ROS, SciPy use WXYZ.
Wait,
Um,
isn't SciPy XYZW and NumPy is WXYZ?
sorry, I might be forgetting. Like,
Yep.
or yeah, see, it's like it's already confusing. Yeah,
Yeah.
yeah,
So yeah, because I mean, I think Jeremy, you made a good point on Slack. Like the more intuitive way is to have W first, but if
yeah,
SciPy is the main thing we're using, and that's like everywhere in the code, then we should probably stick to that convention. And I
Yeah.
guess the main other instance we might use it is what you just raised, Jose, which is like 3D graphic software when we like exported stuff. So maybe we say XYZW, but then just make sure it's really clear.
my vote goes for WXYZ still because I think you can pass in like an argument to like
SciPy to like,
yeah, like okay, like the array that I'm giving is in WXYZ. Like I think
okay,
it's worth
if we could
adding an
do that,
argument.
that's actually really nice because yeah, then we could do WXYZ, and then we could also, it would be very clear every time you're calling SciPy, this is the
Yeah,
convention
it
that's
has
being
a
used. So even someone who doesn't use SciPy would know.
yeah, it has a
Yeah,
scalar first equals true would be the keyword to add.
That sounds, yeah, like a nice approach.
yeah. The reason why I'm going for WXYZ is just like it's easier to do math. like if
Yeah,
we
no,
want to
I
drive
agree.
any,
It's definitely better from that. I just didn't want us to have to like every time we call SciPy be like, I don't know, but yeah, but no,
Yeah.
that argument sounds or like flag sounds perfect.
But I mean, it also like the balance is that like I think that having it easier for math is more important than having it easier for like visualization. So like if if you have a strong case that like okay, but visualization is the main issue or more difficult to solve, then okay, I'm like sabotaging myself, but I'm open to that. I'm devil's advocating myself.
No, yeah,
uh,
no, I don't think that's that important.
So
I mean,
just go ahead.
oh, I guess, yeah, my only remaining concern would be if it adds any computational overhead to have to keep converting. But as far as I remember, we just get the quaternions from the observations, and then once we're in like inside the learning module, we don't work with quaternions anymore, which is where all the heavy lifting is happening with rotations. So it shouldn't be too big of an issue, even if we have to convert once.
yeah, I mean, I think even I think transposing is. I mean, I'm not saying it's nothing, but I think it's like not on top of like what's slowing things down.
Well, yeah, I mean, if we would have to do it for like 10,000 hypotheses that we're testing, it might add up. But yeah, when we're testing hypotheses, we're just working with rotation matrices, so it shouldn't be an issue.
Yeah, and I would be surprised if SciPy supports an argument for it that they don't kind of handle it relatively gracefully. But
Okay. I think the person this most immediately will impact is Jeremy as he's working towards Mujoko work. So you might have to mess around with
Well, that one
quaternion
looks like
conversion.
it's WXYZ as well.
Yes. Cool.
Another plus vote for Mojoko.
Reading through their code.
Oh, not in this meeting, but I'm excited to tell you what we're doing with Monty to make it work with Mujaka. Jeremy should give a presentation at some point about what we're thinking, because that's all sorts of exciting. Okay,
Exciting in a good way. It's all a little bit ominous now.
it's in a good way, but
Okay.
you will
yeah,
feel
it sounded
very.
very ominous.
What we're doing with Monty.
This was a
It's like-
teaser.
Okay.
Trailer. This is a teaser for a trailer. Trailer is coming later.
So sounds great.
Okay. Next to vote item is some abstract classes. Are these needed for testing? May simplify code. If not, also multiple inheritance makes things harder to understand, more and more difficult to extend by other users, I think more often than not.
Okay,
Yeah, I
so
guess
I
this is
added
just
this,
like a
but I think this
perennial.
is address. Yeah.
Yeah.
I added this, but this is address in the sense that so abstraction I think like promotes stronger coupling compared to protocol, like or other things. But yeah, so that's why like I added this, but I think we also talked about this. What are your reasons for putting your names?
Yeah, I guess I think we already have this in the kind of undesirable things, but I just thought it was worth kind of resurfacing that like right now with the different types of learning modules and graph classes and stuff like that, it's really hard for new people, I think, to read the code or even people who are familiar with it. And that a lot of that could probably be collapsed down into, well, yeah, like that would be one
Oh.
approach is just collapse everything down into a couple of layers of inheritance. And then I guess a more extreme thing would be maybe trying like a more modular approach.
Yeah.
But
Yeah, sorry. Okay.
yeah, which we've
Yeah.
not
So
really discussed, I don't think. But
yeah. Okay. So I wrote abstract classes, and then my mind went to like another thing about multiple inheritances. So it's not, so the abstract part is address. That part is fine actually. The multiple inheritance. I think Nils and I like experienced this when we were trying to write like a data loader for DMC. It was a kind of a crazy like kind of gotcha.
So,
It's like
yeah,
you need to
yeah.
yeah.
When
I think
okay, I want to ask a clarifying question. When you
Yes.
say multiple inheritance, do you mean
Multiple levels.
height?
Yes.
Okay, so that's not multiple. That's okay. So
Sorry, yeah.
this is the inheritance hierarchy. I'm gonna switch that.
Thank you.
Okay,
Yeah.
yeah,
I
because
mean,
that's
also,
also what I was thinking of.
Deep inheritance hierarchy.
So
Is
for
that
the
correct?
learning modules, I think we addressed this already, Niels, when we did the refactor like 2 years ago. Before we had all the learning modules inheriting from each other, like we had the abstract class, then we had the graph learning module, then the displacement graph learning module, then feature graph learning module, then evidence graph learning module. So it was like a 6-part hierarchy, and then we refactored it all. So it was just graph learning module and then the 3 types inheriting from graph learning module each. So
Yeah.
there, I think we can flatten that hierarchy as flat as it can be for now, as far as I can tell. But I agree for some of the other classes, like the data loaders, and I think maybe the experiment classes too. Still some more nesting that then might be necessary, or policies, I'm not sure.
Yeah, I mean,
Yeah.
maybe it's not necessary. I guess we could flatten that more if we got rid of the feature in the displacement one. Like, it's kind of to maintain that ability to go lateral that we still have that. But yeah, no, I take your point that it's definitely much better than it was.
Yeah. So I think we just need to kind of think about other like big classes, like besides learning modules, like just taking a look at the sensor modules, how they're connected, taking a look at data sets and data loaders, how they're connected, and just kind of go through the same process.
But for what it's worth, my goal is for every inheritance hierarchy to be one level deep. You have an abstraction and you have instances of it, and that's it. So everywhere I'm in code, I will be attempting to flatten the hierarchy to that always. That's my intent with policies and positioning procedures, for example. Like I do intend to flatten the policies and also to flatten make sure positioning procedures are flat. So
I think that makes a lot of sense because I think that's the challenge is as soon as you go deeper than that, it's when it becomes hard to think about.
For
But
me,
yeah.
it would be useful, I mean, if it's not too much work, to sometime have a meeting where you could just give some tips of alternative patterns to use, because at least to me, like I kind of default to hierarchies sometimes when I'm like, oh yeah, I want to reuse this stuff from that class and just customize this function. So if you could just maybe present like what would be the alternative that would be better for us to use.
a general quick first approximation answer will be mixin. You're trying to share some functionality, so ripping it out as so if you have a class and there's a functionality sitting in there, and you're like, I want to reuse it, instead of going, I'm gonna make a subclass of it. Think of it, the functionality that you want to reuse. How do I rewrite it as a mixin? Then mix it into your original class, make sure everything still works, and then write a peer class and then grab that mixin and put it in there as well. Like that would be the general pattern to reuse
Yeah,
functionality as a
okay.
like Rami has been doing that recently, I think.
Yeah.
Oh, about like mixing, would it be easier to do something? Because like so inheritance is like for me is what's it called, like it's part of the class definition. So instead of passing it as a class definition, like passing it as an argument. So if I need some functionalities of let's say visualizer, I don't know, like let's say that's a class, then the argument is like if let's say my LM needs a visualizer, then like one way to do it is to do just pass in a visualizer instance as an argument and then just call viz dot whatever function we need from that class, or so this is called, I think this is called like dependent injection, right? Something like that, dependent or compositionality.
Yeah,
It,
compositionality. That's actually the
yeah,
better way. Sorry,
yeah.
my brain was stuck on make sense. What Jose said is probably the most preferred way is compositionality, especially So I would go with what Hodge said instead as the default.
Okay,
So,
I'll post
and
the
just to
resources.
clarify the difference exactly. So, sorry, with the compositionally, how is it injected? Or
I don't know. I'll post an example. It'll be much clearer. It's very easy to. I know this is a obscure term, but like, it's actually very easy to understand. So I'll just post an example in Slack.
Yeah, that would be great.
nice.
Yeah. I was trying to think something from the code base, but my mind is blanking, so sorry.
And so with the very first question on the top, you suggested for the abstract class to have like another class that's like simulator environment, from which then I assume some other classes would inherit. Is that a case where you would say hierarchy is better because it makes it clearer to kind of distinguish types of classes, or would you also use compositionality there?
I would, so environment would be abstract, simulated environment would be specific, like concrete, and that's it.
Yeah.
Nothing inherits from simulated environment. Flat.
So then if I want to have a habitat environment, what would I do?
You would create a habitat environment.
So what is simulated environment for? It sounds like it's like general to any simulator.
I think this is an abstract, right? I might have misspoke. Like we have an abstract environment, an abstract simulated environment, and then habitat would be a concrete
So,
implementation
as
of
in
this
simulated environment does not inherit from generic environment.
Yeah, maybe there's an environment protocol. I don't know. We have to think about it.
Okay.
But that's a great example of yeah, so it's like specifically what would we do to implement habitat environment? Yeah.
Yeah, I don't know if this is if this is like a standard or like yeah, it'd be I guess interesting to look into this more, but it feels like if the second level of inheritance is still abstract, as in it's not implementing methods, but it's just defining them, it still feels like that's easy to read. As in, I could imagine, yeah, us having this very abstract environment which covers everything, including simulated environments, maybe robotic ones or whatever. And then we have simulated environment, which is like, oh, you should have add object, all this kind of stuff, but it's all not implemented. And then, so technically there's 3 levels, but then it's the third level that implements everything concretely. But at least when you're reading the third level, going up a level isn't like you're not having to understand what a function is actually doing. Going up a level is just telling you this is the structure, this is the skeleton kind of this class, and going and then having the top level tells you, okay, this is how it relates to other ones. But maybe it's not even helpful to have that top one. I don't know.
Yeah, so thinking about like answer is kind of forming in my head because again, this is like a rule that really don't want to break. And so what I maybe would do would be habitat environment inherits from environment, and it also implements the simulated environment protocol.
Okay.
Right. That makes
Yeah.
it one deep. It's just an environment, but simulated environment also has an additional protocol that these environments do.
And then when we have like an experiment class that would like an experiment class for running on a simulated environment, it would check whether our environment is following the simulated environment. Like has that in it.
Right.
Okay.
So if you pass an environment to experiment, it's like, hey, this is not a simulated environment. What's wrong? Exactly.
Yeah. Okay. Cool. Thanks.
Yeah, I just want to highlight like just to really try not to break the rule forces these types of solutions, which end up being more intuitive. So it's like when you hit a wall of a rule, just don't give up on the rule just yet. Like it will guide you to a solution. That's how I feel what happened here. I was just like, once we say, no, let's keep this one level deep, how else can we solve the problem? And that should help.
And so the reason why this is preferred is because like Well, it's probably just familiarity for me, but it still seems to me if it's a hierarchy, it's easy to follow the path versus if there are like multiple things in there, I have to kind of, there's like a fork and I have to decide where I want to go first and I have to come back and then I have to go to the other place to see what's there. So I feel like I could make the argument for it being harder to follow.
Yep. Niels and Jose said the opposite.
Well,
So there's
for
that.
me, the difficulty is if yeah, like kind of what I was saying before. I feel like if the parent class is also like making concrete implementations of methods, I think that's when it's more likely to get confusing. Because then it's like some things are calling like super and some things aren't, and there's just like a lot of back and forth. I feel like as long as the parent is still abstract and it's like, oh, okay, this parent one is just adding these abstract methods, which is what makes it unique. Like this is what makes it a simulator thing. I feel like that, yeah, but maybe like Vivian says, it's also just familiarity. That would be equally easy to kind of read and understand, I feel, but also happy to stick to the rules.
And also when you're like, when it starts not to make sense, just let's, ping me, ping Jeremy, let's have a conversation. It'll be much easier. It's somewhat difficult to dish out this generic guidance. It's like much easier to do it specifically on the problem because then it's then it's easier to provide a solution for a specific instance of what is happening than to talk in generalities and then apply them.